Hey guys, Mr. Jenkins here with another lesson from Chapter 5. We have basically this and one more before we're kind of through the end of, the main part of it. I might give you 5, 7 as like maybe a bonus question. Might just skip it all together so we can focus on the main stuff. So in 5.5, we're talking about some theorems about roots of polynomial equations. Okay, we've already talked about how to solve them, but these theorems may help you to solve some of the maybe trickier ones. So there is a rule in here called Descartes rule of signs. So there's one like on the homework about that. It's pretty simple. So instead of putting it in the notes, I'm just going to attach like a 2-minute YouTube video, and you guys can ask for help on that one if you need. Everything that I'm going to show is maybe a little bit more important. Okay. So our goal when we have a polynomial equation is to find all the roots, which are also known as zeros or solutions. And even you could add to that x-intercepts. Okay, so all those things kind of go together. All right. The reason I guess they don't put x-intercepts is because that doesn't happen for imaginary solutions. Okay, but for real solutions, those are x-intercepts. All right, so one of the big theorems we're going to look at is the rational root theorem. Okay, where P, it's P over Q, where P is, let's see, which one is P? Get this right here. Let me just look later in the notes. So P are your factors of your constant. Okay, so these would be P here, and then Q would be factors of the leading coefficient. So these would be Q. All right, so some examples of rational numbers are it's anything you can write as a fraction. So I put some examples, but like 0, the square root of 9, -8 over 2. Any number that can be written as a fraction, -8 over 7, 0.97. The list goes on and on forever. One that kind of people forget sometimes is a repeating decimal. All right, so those are rationals. Irrational numbers are one famous one that doesn't end and doesn't repeat is pi. Other than that, we're talking about square roots of non-perfect squares or cube roots of non-perfect cubes and so on. So like the square root of 8. Okay, so we're talking about rational roots, right? That's why it's P over Q. It's written as a fraction. Okay, so let's just go ahead and practice that. And this is any, based on this theorem, it's just that this is all the possible roots of this equation. Okay, so in other words, if you were like trying to solve this and it couldn't be, you couldn't find them on your calculator, let's just go ahead and plug that in. So looking at A, we have this equation. So it's 15x to the 3 minus 32x to the 2 plus 3x and plus 2. So if we looked at our graph, we're going to see, let me zoom in a little bit. Let's go from -2 and from -2. I'm just zooming in a little bit so we can see a little bit closer. All right, so now we can definitely tell there are no whole number intercepts, right? So those could be irrational or they could be rational, right? So the rational root theorem could help you to come up with that if, say, you didn't know how to factor this, which would be difficult, right? So let's go ahead and look at it. All right, so P over Q, okay? So remember P, your numerators are going to be this. So P is going to be your factors of 2, which are 1 and 2, okay? And then Q, that's a different color. Q is going to be, your list of Q's are going to be your factors of 15. So 1 goes into 15, 3 goes into 15, 5 goes into 15, and 15 goes into 15. All right, so then we just do P over Q, okay? And also you have to think about the plus or minus, all right? So you put a plus or minus in front of all of them. All right, so and then we just start to kind of form our list. I like to just start with the P's and then go from there. So let's start with the ones. So we're gonna do plus or minus, and then we just do 1 over 1. Plus or minus 1 over 3. 1 over 5. And 1 over 15. Right, so this looks like 1, 2, 3, 4, but it's actually 8 possibilities right there based on that set of P over Q, and then we do the 2's over all those. All right, so we also have and plus or minus 2 over 1, plus or minus 2 over 3, 2 over 5, and 2 over 15. Okay, so your final list, you want to kind of take out any repeats, right? So there's no 2 up there. There's no 2/3 up there. There's no 2/5 up there. And there's no 2/15 up there, right? So all of these are included. Sometimes you'll have some repeats, so we'll do another one so we can see that. So our final list, what you would put, into your Math Excel answers are all these, and you just want to reduce these 2. So we would say plus or minus 1, plus or minus 2, and then all your fractions. So 1/3. Let it catch up real quick. 2/3. This is kind of a tough one to start with because we have tons. 1/15, and then you go through your other list as well. So plus or minus 2, 2/3. Sorry, we already had 2. Didn't need to write that again. So then 2/3, and then you'd have 2/5. That should be a 5. Got in a hurry there. All right, so anyways, to complete the list, you'd have your 2/3, that should be a 1. Your 2/5 and your 2/15. Okay, so can we tell what's what? Well, maybe So that looks like it could be maybe negative. It could be any of these, negative maybe, or it could be, it could be some of those too, right? So you'd have to do something else to check, right? Your final list, and we know how to divide now, right? So we could check with division, all right? That's what you would want to do, right? You kind of get a visual idea from your graph, and then you would check with division, okay? If that makes sense. So just so you see it on the board, I went ahead and finished that list. Like I said, that was kind of a bad one to start with. So let's look at example B here. All right, and then we might work all the way through that one. Actually figure out what the roots were. Okay, So let's get a visual first. So we have 2x to the third. 2x to the third plus x squared. I always forget to do that. When you do x to the third, you got to arrow out. So plus x squared minus 7x minus 6. And we go to graph. I might have to do some zoom in. All right, so looks pretty good. It looks like we might even have a whole number root there. I think that's -1. Yeah, and we have another one which is +2, right? So this one's a little bit easier, but let's see how it fits into our roots. All right, so remember our p's come from 6, right? Doesn't matter that it's -6. You just think of 6. So our p's are going to be any, that's our numerators, any factor of 6. So 1, 2, 3, and 6. Our denominators, our q's, are going to be factors of 2, so 1 and 2. And then we put a plus or minus in front of everything. Then we just have to remember it's p over q. So my one row would be plus or minus 1 over 1. And plus or minus 1 over 2. So check that off. Then I have plus or minus 2 over 1 and then 2 over 2. All right, check that off the list, and then we just basically repeat. 3 over 1, 3 over 2. Check that one off, and then you got 6 over 1 and 6 over 2. All right, so after that, you just want to eliminate any repeats and do your simplifications, right? So let's see if we can find any other 1s on here. All right, 2 over 2 is 1, so that's a repeat. And then there's no other 1s. So any other thing equal to 1/2 will eliminate. I don't see anything else. Anything equal to 2 will eliminate. I don't see anything equal to 2. So just keep that. Is there anything equal to 3? Doesn't look like it. 3 over 2, no. 6, no. Okay, there was a 3, sorry. I said there was no repeat for 3, but that's 3. So just to kind of formalize the list then, we will simplify. So we have plus or minus 1, plus or minus 1 over 2, plus or minus, that's 2, plus or minus 3, plus or minus 3 over 2, and plus or minus 6. Okay, just kind of listing them all out in reduced form. All right, so like we said, you know, we can see on our calculator that -1 is a root, right, which we see as a possible root, so that's good. +2 is a root, which we see as a possible root. And then the last thing would be, you know, which of your fractions is this equal to? Is it -1/2? Is it -3/2? So which one is it? Well, it's kind of hard to tell because it's like, is that your -1 or is that? That would differentiate. And you could do that by dividing, right? So you could divide this down, which I won't do now for time purposes. But once we get to the kind of studying for the test, I can show you how you can really use this thing. Okay, I promise you can. All right, so then we finish with some stuff we kind of already know about. All right, so there's this conjugate root theorem. Okay, so we talked about conjugates when we were doing like if it said on your last test, if you had something like 2 plus I over 3 minus I, then it would just say simplify, and you would have to know that the conjugate of that was 3 plus I, right? So you'd multiply by 3 plus I over 3 plus I. That's a conjugate. Okay, but here we're talking about real numbers, right? So now we're talking about also if we have a plus the square root, like a plus or minus square root, all right? That also has a conjugate. So an irrational number, in other words. Translation, irrational roots will always come in a pair of conjugates, right? So this means if you have 6 plus the square root of 3, then you also have 6 minus the square root of 3, right? Which is usually written as 6 plus or minus the square root of 3. If we have negative square root of 5, we also have positive square root of 5. Right? And then same thing for those complex roots. So really, these are similar to irrational numbers in a lot of ways. So if 5 minus 7i is a root, then so is 5 plus 7i. If 3i is a root, then so is minus 3i. Okay? So what we're going to do then is find those conjugates, right? So it just says a polynomial p of x with rational coefficients has the given roots. Find 2 additional roots for p of x. Okay, so understand that this is a rational number, so this does not apply. So we're looking at this one and this one, right? So the conjugate of 3 plus the square root of 7 would be 3 minus the square root of 7. The conjugate of the conjugate of negative 4i would be positive 4i. So overall, we would know, even though if they said a polynomial contains the roots 2 over 5, 3 plus the square root of 7, and negative 4i, you would have to know that it also includes these two, so that was a 5th degree polynomial. Okay, I'll leave B for you to do. All right, now we get into writing the polynomial. So now we're going to use what I just said there. Okay, so we'll start with an easy one. This one just has rational roots. So we would say p of x equals, and then use your linear factors that produce these roots. So x minus 7 would produce 7, and x plus 10 would produce negative 10. All right, and then we would just multiply. Okay, another note that I should have probably said at the beginning, you have 1, 2 roots, so this should be a 2nd degree or quadratic equation, right? Which we know that's what we get when we take a binomial times a binomial. Okay, so we have x squared. I'm going to save a little bit of space here. We'd have plus 10x and minus 7x to make plus 3x. And minus 70 at the end. Okay, so then can we check our work? We can, right? We could just plug it in. Let me fix my window to where all that fits. So my one root is negative 10. Let me make that just like negative 11. We'll go to 10. And then it doesn't really matter on the y's, so we'll just look at the x's. So we'll see if what we just did, well, I forgot to type it in, sorry. I was like, that didn't look right. So x squared plus 3x minus 70. Graph it. And there you see our negative 10. There you see our positive 7. So then you know it works. Okay? So looking at B is a little trickier. All right? So if it contains 5i, then it's also understood that it contains negative 5i, right? And then so we just multiply that out. So we'd have x minus 5i produces 5i, and x plus 5i produces the other one. All right, so let's think through this one. So you got x times x is x squared. You've got 5i times x, and then you got negative 5i times x. So those cancel each other out. And then our last term would be negative 25i squared. So guys, just like it's just like a difference of squares. A plus b times a minus b, right? And this is just like what we did on the test. It's just like when we conjugate, right? We get that denominator, right? So so what we would have then is x squared plus 25. For our function rule. And we could just say equals f of x. Because remember, that's negative 25 times negative 1. Sorry, the board is doing this. All right. Let's do maybe one or two more. Let's just do those maybe last two at the bottom. Those look kind of maybe tricky. And then I'll leave, well, let's do one of each. All right, I'll do C, and then I'll do F. Okay, so it's understood here that we also have the square root of negative 5. No, we have negative square root of 5, and then we also have 4i. You can start to take some shortcuts on these, if you start to see them, right? So think about how negative 4i and 4i are similar to these two, right? But let's go ahead and do it the long way. So you'd have your roots would be x minus square root of 5, x plus square root of 5, and then the same thing for your I term. So x plus 4i and x minus 4i. And all these are worked out on the notes too, okay? All right, so let's think about this one. And guys, you'll start to notice a shortcut, right? It's always a squared minus b squared, right? So this one, a squared is going to be x squared. Let me do that in a different color. X squared. And then it's going to be minus b squared, right? So minus the square root of 5 squared. What would that be? The square root of 5 squared would just be 5. So x squared minus 5. Got to use these shortcuts when they're available. And then this one would be a squared, so x squared minus b squared, so that'd be 16i squared. Which we would want to clean that up. So really, this is just x squared plus 16, okay? So my last step then would be to multiply what I have, right? So I'm just going to change this to x squared plus 16. So times x squared plus 16. Just like the last one gave us x squared plus 25. Like, there are shortcuts once you get used to it. Okay, then we multiply it out. X squared times x squared is x to the 4th, which makes sense since we had 1, 2, 3, 4 roots. Then you have plus 16x squared, then minus 5x, minus 5x squared, and minus 80 at the end. Okay, we have two like terms in the middle. So our final answer there is going to be x to the 4th plus 11x squared minus 80. just say p of x, or call it something generic, equals x to the 4th plus 11x to the 2 minus 80. And then you could check some of that kind of on your calculator, but you wouldn't see the imaginary roots, right? And the square root of 5, you're not going to be able to see on a table or something, okay? So let me just do D and then, F, and then we'll call it a day. It would just take forever for me to show all these, all right? So if it has negative 9 minus the square root of 2, you'd be tempted to say the conjugate is 9 plus the square root of 2, but it's actually negative 9 plus the square root of 2. So just be careful with that. So this one is just a little bit different, so I'm glad I showed this one. Right, so your zeros would be x plus this. Let's see what this looks like after we have it all. And there ends up being a shortcut too here, but it looks nasty at first. I am glad that I showed this. Didn't just assume they were all the rest the same. So x plus 9 minus the square root of 2 times x plus 9 plus the square root of 2. Like I said, that's pretty nasty looking. In MathXL, they show you a shortcut, okay? But what you're really doing is you're multiplying 3 terms times 3 terms, right? You end up with 9 terms, okay? And so I don't really know how to, I'm not going to have enough time to show that all, but I'm happy to show it in class if you'd like to see it. What you should end up with is x squared, when it's all said and done, plus 18x plus 79. All right, so these can be tricky for sure. Sorry again about the long video, but this is just kind of technical stuff. So I'm going to keep making them, I think, where you can skip around. I think you guys probably like that a little bit better. So hope this helps, and let me know what kinds of questions you have.